Good morning. I am so sorry I'm not there today. I'm not feeling well and I just don't want to get super duper sick. So I opted to stay home today. Anyhow. So what I have for you today is a project. So if we go to your project, so this is the trig project 4B, and you're going to be able to work on this in class this week. You probably won't need all 3 days, but it'll be there. So here's, if you go to trig project 4B, this is what is required of you. So you're going to choose a international city. So you're going to choose some city. I chose Reykjavik, Iceland. I have a reason for that, and I'll explain it later. And you're going to state its latitude and longitude coordinates. Then, using an almanac or other resource to determine the length of daylight for that city for each day of the year, you're going to record your data. Now, you do not need to do all 365 days. What you do need to do is have a decent representation. I don't think 12 is enough. I don't think that gives you a good enough picture of the full year with the data that's out there. So I think what our best option to do is to do 52, and that would be once every week. So that's what I did, and that's my suggestion for you. Once you have your data, you're going to make a scatter plot of that data on paper. Sketch a curve of good fit through it. So once you have your data collected, you're going to sketch a curve of good fit through the data. Then you're going to answer these questions, which is the length of time you collected the data for, the shortest amount of daylight, and what day number it is, the longest amount of daylight, and what day number that is. And would you represent this using sine or cosine or something else, and justify that using mathematics? Okay? So the reason for these questions, the length of time you collected for data and for days, it's going to be 365 days for everybody. 365 days. The reason I have asked you about the shortest amount of daylight and the longest amount of daylight, anybody want to know why? Yes, it is because the shortest amount of daylight gives you your min, the longest amount of daylight gives you your max. And in doing that, I've been able to help you calculate your amplitude. Because remember, if you do the max minus the min divided by 2, it gives you the amplitude. And if you do the max plus the min divided by 2, it gives you your vertical shift. So there's half of the questions you need. And since everybody's period is 365, the only thing you really have to calculate is your horizontal shift or your phase shift. When it says, would you represent this with sine or cosine or something else? When I looked at the data, I saw that it was a sinusoidal curve. So that meant I could use sine or cosine. So that's what I did. And I chose to do cosine because I knew the max. And since I knew what the max was, I could figure out my phase shift very easily, because however many days that was that it occurred, that was that. And then for number 5, all it's asking you to do is complete the following based on your choice for 4D. So what's your period? Everybody's period is going to be 365. What's your amplitude? That's your max minus your min divided by 2. What's your phase shift? That depends on whether you're using sine or cosine, and so that you'd have to think back to what we did last week when we were doing those modeling questions. What's your vertical shift? So your vertical shift is going to be the max plus the min divided by 2. And then write your equation to model the data. That's what I'm asking of you. Okay? Now, what does this look like? Well, I'm glad you asked. So if I go to back over here to the overview on its learning, there is a folder here called Mrs. Finney's Quarter 2 Trig Project. So this is like what you're going to need to turn in. All right. So I have my collected data. So basically I wrote everything down on a piece of paper because I'm old and I'm old school. So I wrote down the day number of the year, and I wrote down the date of the year. So I was sure that I got through everything. I had a student yesterday who was doing this in a spreadsheet. So in the spreadsheet, she was just recording the day and the date, and then she wrote the time, the length of time. And where did I get that information? I'm glad you asked. The best way to get that information is to go to timeanddate.com. Okay, and so right now I have Baltimore, Maryland. So if I click Baltimore, Maryland, USA, I've got Baltimore, Maryland. And see down here, it says it's 21, and the length of time today, does it say the length of the day on there? Yes, today's day length is 9 hours and 38 minutes, which is a minute 13 seconds longer than yesterday's daylight. So if I click this day length, this is the beautiful part of this website. So it shows you, first of all, what your curve should look like from January to January. All right. And then if you go down here, it shows you what the daylight looks like. So you can see where the daylight is between what hours. And then if you come down here, it tells you the day and the length of that day. So January 1st, the day was 9 hours, 27 minutes. So I converted everything to minutes, so I didn't have to worry about fractional hours when I was plotting my points. So to convert this to hours, is 1 hour is 60 minutes. So I would do 9 times 60, which is 540. And then I would add 27. So 540 plus 27 would be 547. Then I would go down a week. So 7 plus 1 is 8. So that's the 8th, and that was 9 hours and 34 minutes. So 9 times 60 is 540. 540 plus 34 is 574, 574. And then I would go down 5 more days. I'm sorry, 7 more days, which gives me to the 15th. So you can see that's where I got my numbers. And I just followed this. Now, all of this is doing is telling you whether the day is getting longer or shorter. Now, this is for 2022. And you can use 2022 if you want. What they're doing is making predictions based on past history. If you want to do it for 2021, then all you do is click 2021. Okay? Boom. And what you should notice is there's not that much change. 948. 928. The 8th is 934. The 15th is 943. So there's not that much difference. But once you commit to a year, stick with that year. So then you go to February. Now the cool thing is February, click go. There's 31 days in January. So that means that February 1st is day 32. All right? So I probably don't need day 32. I need day 35. So this is 32, 33, 34, 35. So on February 4th, it's 10 hours and 20 minutes. So 10 times 60 is 600, plus 20 is 620. Boom. Okay? And there you have it. So that's what you're going to keep doing. So that's why when you look at my data points that are collected, you'll see I have the date after them. Okay? So if we're adding 7 each time, you're going by weeks. Now, I stopped my data here at 183 because I made a video last year for this, but you're going to actually do all the way to 365. Okay? Then what you're going to do is you're going to take a look at your length of daylight picture. So I can't rotate this, which is fine. So you can see that what I did then was I took my data and I made this scatter plot, and then I sketched my graph over it. And as you saw, I said earlier that my maximum point was at day 169. So I said I was going to use cosine. It looks like a sinusoidal graph, so I can choose sine or cosine. My phase shift is going to be 169. Boom. My vertical shift was 757. So it's somewhere in here. So if I wanted to do sine, I would just have to go back there and find what the phase shift is. Okay? And then I answered my questions. Again, I answered my questions on paper and then just took a picture to submit. But you can answer your questions in a Word document if you want and put them in, or you can answer your questions in the window provided for you. That's fine as well. And then what I did is I wanted to check this. I just didn't trust that I was right. So I put my data in Desmos. And by putting my data in Desmos, it made a scatter plot. And then I was able to put my graph in. And see if in fact my graph was right. So did my data and my graph match up? And I was pretty happy with it. Okay? Any questions there, you can email me, but that's what you're going to be doing. All right? Now, if you are a GS class, then I already explained everything to you. But if you're a GS class, now what you're going to do is you're going to look up the city that you studied, and you're going to find out how they use that length of day for their economy, how the length of day impacts them. So one of the things I knew about Reykjavik is that they have where is it? Is that they have a